Several times, we need to add few loads in a model which are temporary or case specific, and we don't need these loads for final analysis and design. For example, loads to check if a second order analysis is required or construction and transportation loads. Do you know, without removing these loads, how we can inform STAAD not to consider this for analysis and reduce the overall analysis time? Hi, I am Surajit Ghosh, and in this video, I'll talk about a feature of STAAD which is very useful for modeling any large steel or concrete structure, the reference load case. Using this, we can add hundreds of loads in a model and use few selected loads for analysis and design without affecting the overall analysis time. There are two types of loads which we can define in STAAD. First, we can create a primary load case, which is nothing but an isolated load. Normally, we define all similar types of loads under separate primary load case, like all gravity loads under dead and live load case, wind or seismic load from each direction under separate primary load case. Second type of loads are the combination. Either we can create a load combination case and combine few primary loads or other combination cases with relevant load factor, or we can create a repeat load case to combine other loads. There are several differences between a repeat load and a combination load, which I have already discussed in my previous video on load conversion. It's a common practice to add the isolated load under a primary load case. It is okay when we perform linear static analysis using load combinations, as we need to analyze each primary load combined under a load combination case to get the results. But when we perform a second order analysis like a p-delta analysis, then a repeat load is required, and for such case, analysis results of primary loads are irrelevant. We know that for a repeat load, all primary loads are first combined and then analyzed. So we don't need the results of individual load case. These are used only to generate the combinations, and if there are several such primary loads, more analysis time is required, which is nothing but a waste. Remember this model which I have used in my instability series? In this model, I have defined two primary load case, one gravity and one lateral load, and discussed how the isolated lateral load, which is not combined with the gravity load, produce incorrect instability condition. Primary loads like gravity and lateral loads cannot act individually on a model. Seismic load without any weight of the structure is not a realistic condition, and to avoid such faulty condition, it is better to avoid analysis of primary load case. For such case, when we are concerned about the analysis time or want to avoid few loads during analysis, reference load is a perfect choice. A reference load is nothing but a primary load which is available under the load definition, but the main difference is program does not analyze any reference load. This is like a dummy load case which is not used for analysis until we call it from a primary load. To analyze a reference load, we can add it under a primary load case, which then behaves like a normal primary load, or we can directly combine multiple reference loads under a repeat load case. This gives us the freedom to add as many reference loads as possible without increasing the analysis time and results. For example, we can add a temporary load or stage load under a reference load case and use it during initial analysis. During final analysis and design, we can just forget this load and use other gravity and lateral loads. As this reference load is no longer included in any primary or repeat load case, program does not consider this load for analysis. We can create a reference load case with different load types like dead, live, or snow load. Along with that, another load type is available here, which is the mass reference load. We can define the seismic weight or a mass model under a mass reference load case, which is used during static or dynamic seismic analysis. I have already discussed this in my previous video on modeling for seismic analysis. I will also cover this in detail in the next video. We can add most of the load items under a reference load case like cell point, member, node and blade load, floor load. Lateral loads like wind and seismic loads are not available here as these loads are generated during analysis using respective wind and seismic definition. It is not possible to add any generated load including wind, seismic and moving load under a reference load case. Reference load is very useful if we want to eliminate analysis of the isolated primary load or any load which is not used for final design. This will not only reduce the results but also reduce the overall analysis time. We can add all the gravity loads including snow, dust and temperature loads under respective reference load case and then use these loads to auto-generate combinations as a repeat load case. Wind and seismic loads must be specified under primary load case unless these loads are calculated manually and applied as a nodal load or a UDL. In this model, two dead load, one live load, and a temperature load case is defined under reference load. Repeat loads are generated considering loads from reference and primary load case. During analysis, only these primary and repeat loads are used and all these reference loads are skipped. For a large model with several primary load case, I always suggest to define these loads under reference load. For a medium or small model with few primary loads, we can follow the normal procedure. Another major advantage of the reference load is the use of mass reference load for seismic analysis, which I will cover in the next video. Thanks for watching.